All right, so let's start off with number 1, and we'll just do let me do a 1 or 2 from each, and then you can let me know if there's any.
Okay.
I won't do all of it, but just so we get a taste of some of these types of problems.
Okay.
Okay, so number 1 says find x and y intercepts. So here's a little bit of a recap. So if I want to find x and y intercepts, to find x-intercept, I'm going to replace the y with 0 and solve for x.
Okay.
So for instance, if I had a linear graph here, a linear graph here, notice that my x-intercept, such as 3, 0, for instance, has a y value of 0. So that's why we replace y with 0 and we can solve for x.
I see.
Just in the numerator, though. If there's a denominator, we completely ignore it. We just look at we just set the numerator of the function equal to 0.
Okay.
To find y-intercept, for instance, let's say, and the y-intercept could look like 0, 2, right? Y-intercept.
Right.
So y-intercept has an x value of 0. So if I replace x with 0 and solve for y, I'm able to find my y-intercept that way.
Okay.
Okay, so let's try number 1.
Okay. So I'm going to replace my. So we're trying to find y. So it's going to be y equals 0 plus 0 minus 1. So that's -1.
Y equals -1. Okay, so this is the x or y intercept.
That is the y-intercept.
Yeah, y-intercept.
No. Wait, yes?
Yep, that's right. Yeah, you replace
Okay.
your x with 0, and you solve for y. So 0, -1 would be a point that lies on the y-axis.
Oh, okay.
Okay, how about finding the x-intercept?
Okay. Okay, so this is going to be 0 equals x squared plus x minus 1. That's x squared.
So is this factorable?
No.
Yeah, it's not factorable. So do you know what we can do if we can't factor?
The quadratic formula?
Yeah, we got to do quadratic.
Okay.
So I'll remind us of that. Good. A is 1, B is 1, and C is -1.
Okay.
So how many solutions is that? How many x values is that?
2.
2, that's right. So we have 2 x-intercepts.
Oh.
So this is a quadratic function. So what that tells us is that the graph is going to hit the x-axis in 2 different places.
Oh. And that we could just leave it like that, right? We don't need to write it twice.
Right, we can leave it like this, but just so that we're, if we were to find the two decimal values, we would have to look at it this way. It'll be -1 plus square root of 5 all over 2, 0. That's whatever that decimal value is. And the second x-intercept is -1 minus root 5 all over 2, 0.
Okay.
One y-intercept. In this case, we have two x-intercepts.
Yes.
Good. All right, let's try part B.
Okay. So the y-intercept, 0 minus 1, square root 9 minus 0. 9 minus, okay.
You want to find y-intercept first, okay?
Yes. So y equals -1 root 9, which is y equals -1 times 3, right?
That's right.
So y equals -3.
Mm-hmm.
And then find the x-intercept, replace the y with 0. But would I still have to use a quadratic formula for this as well?
Well, let's see what happens first. Let's just go ahead and replace y with 0, see what that looks like.
So 0 equals x minus 1 times square root 9 minus x squared.
Mm-hmm.
Okay.
So there's no need for quadratic formula. Any thoughts as to what we can do here?
Oh, could we make it, could we take the square root, like get rid of the square root by making it 3 minus x? Or that?
Not quite.
No,
Not quite.
okay.
However, there's something about the fact that there's a 0 here. And we can think of these as two separate parentheses. This is help us out if we write it this way. So basically, this is factored form.
Oh.
So we can really treat these now as two completely separate expressions. We can solve for them independently of each other because there's a 0 here. And then we have two parentheses that are separated by multiplication. Now, there's a plus in between, then we're kind of stuck. But here, it's nicely separated by multiplication, and there's 0 here. So we can just draw a line down the middle.
Okay.
And just really treat them independently of each other.
So x equals 0 and x equals 3?
Well, this side here, what's x equal to?
Oh, 1.
X, yeah, I got to add 1 to both sides. Okay, so there's one x-intercept. There's another one. How do you think you would go about solving this x here?
Oh, wait, we would have to, well, we'd have to move the x squared to the other side to get x by itself, but wouldn't we have to also do like square root of x squared equals?
Okay, well, not square root. What can we do to undo this thing that's
Well, we
getting?
can multiply it by 1/2. Or 2?
Okay, yeah, but not by 2, but we're going to square both sides.
Okay.
If we square both sides, we can undo this square root that's getting in the way.
I see.
So what does this become?
That becomes, so that'd be 9 minus x.
9 minus x squared. So the squared is not going to touch the squared inside. It's just going to do this. It's just going to take away the square root.
Got it. So then we have 9 equals x squared and x equals 3.
Okay, that's part of it. What happens when we take the square root of both sides of the equation?
Oh, plus minus.
Yeah, plus or minus.
So we technically have 3 x
Yeah, we
values.
do. Yeah, we have 3 x-intercepts here. Yeah.
It's a lot.
Mm-hmm.
So what would that line look like?
Yeah, I don't think this will be a line. This is almost like a cube root function.
Oh.
Let's see here. So this will be 1, 0. Because we have plus or minus 3, right?
Right.
It's definitely a function. Let me see. This is not something that is familiar.
Right.
Doesn't really match any of the parent functions that we're used to seeing. Let's see what it looks like. It's probably strange looking. Let's see. So I have it into a calculator here. I'll do some 6. Just kind of stops, isn't it? Let's see. Yeah, it's kind of strange. I'm not exactly sure what this graph is looking like. I think there must be some sort of a, yeah, this graph is not showing up. Yeah, we do it algebraically, but graphically it does seem a little bit unfamiliar. So,
Okay.
okay, so let's try part C, and then we'll move on to something else. Okay.
Okay. So finding the y. Are all the x's zeros or just the numerator?
Oh yeah, let's see. Okay, so if I want to find x-intercept, I'm just going to set the numerator equal to 0. If I want to find y-intercept, I replace every x with 0, even the 1.
Oh. Okay. So it should be y equals 0 plus 0 over 0 plus 1 squared.
Mm-hmm.
Okay.
What does that become?
1. So y equals 0 over 1.
Which is?
That's not possible.
It is possible. It's just anything, if it's a 0 over a non-zero, then we consider that just
It's
0.
0. Okay.
So we have y-intercept at 0, 0.
Okay. So then our x-intercept is going to be 0 equals x squared plus 3x over 3x plus 1 squared.
Right, but with x-intercept, we just care about the numerator.
Oh, okay.
Yeah, if we set the
So-
denominator equal to 0, that's something else. That's something that if we're looking for a whole or a vertical asymptote, then we can look there. But it's just the numerator that's going to give us anything about our x-intercept.
Okay. So 0 equals x squared plus x. So wait, so how would I find the x-intercept for this? Would I like factor it?
Yeah, take out a GCF.
Okay. I could take out x,
Mm-hmm.
and then that'd be x plus 3.
That's right.
Oh, so then our x values would equal 0 and -3.
Yeah. So you see that it's a duplicate, right? So anytime your graph crosses the origin, it's going to be considered an x and y intercept. It falls into both
Okay.
categories.
I see. So y equals 0, x equals -3, and x equals 0.
Yeah, so my x-intercept is 0, 0, -3, 0, and then my y-intercept is the same thing as my x-intercept, 0, 0.
Okay. Got it.
Okay, so let's look at number 2. It says find points of intersection. So if we don't find points of intersection, we can either use elimination method, or we can use substitution method, where we solve for one variable and insert into the other equation. Or we can just line them up and do elimination method. I feel like elimination method is not, I just don't see it as much. I feel like substitution is one that we're going to see more often than not in
Okay.
our calculus course. So let's skip A and let's look at B here.
Okay. A and B. Okay.
Let's start with B. So looking at B, we have 2 missing variables. That's why we need 2 separate equations so that one can kind of help each other out in terms of solving one variable at a time. So any thoughts as to how we can?
We could solve for y from the 2x plus y equals 10.
Yeah, let's target the easiest variable here.
Yeah, so that'd be 10 minus 2x.
Okay.
And then we could plug that into the other equation, right? And have x squared plus 10 minus 2x squared equals 25.
Good. So now we have everything in terms of one variable, and even though it's a lot messier, at least we have a way towards our answer here.
Yes.
All right, so now practice our algebra here. We got to FOIL this out correctly and go through factoring stuff.
Okay. So 10 minus 2x, 10 minus 2x. Okay, so that's going to be so 100 minus 40x plus 4x. That's it, right?
4x squared.
Yeah, sorry, 4x squared.
Yeah. All right, combine my terms.
So 100 minus 25 minus 40x plus 4x squared plus x squared. That's 100 minus 25, 75 minus 40x plus 5x squared.
Mm-hmm.
Okay. 5x squared minus 8x plus 15 equals 0. And then I would, okay. So 5x. So x equals 5 and x equals 3.
Okay, let's see. Yeah, that's right.
Okay. And do we not worry about that 5 that we took out?
That's right. This one, if we set that equal to 0, it's not going to give us anything, so we just basically ignore it. There's no variable here, so we're going to ignore it. Yeah.
Okay.
So x equals
5 and x equals 3. Oh, wait, so that means we can plug it into the y value, right?
Mm-hmm.
Okay.
You're right, because we want to find full order pairs.
Yes. So that would be 10 minus 6 and 10 minus 10. So y could equal 0 or 4. Is that right?
Let's see. Okay, so let's do 5 first.
Okay, so that would be 10 minus 10.
10 minus 10, yeah. So what's the order pair there?
0, 0.
Well, it's going to be 5, 0, right?
Oh, 5,
And
0,
for
right, because you have to
5,
put
so.
the.
Okay. Second order pair.
3, 4.
Good. And then we typically use this notation, y of 5, y of 3, to indicate that we're inserting these independent or these argument values into the function we get for y value.
Okay.
So visually, what this could look like is this x squared plus y squared equals 25 is a circle. And this is a line. So this tells us that this line is going to intersect the circle at 2 different points, at 5, 0, and at 3, 4. So, you know, that's why there's 2 solutions.
Okay.
Okay. Yeah, algebraically, C and D are also very, very helpful to go through as well.
Okay. So C?
Mm-hmm.
Okay. y equals 3 minus 4x, y equals negative x.
Just find the points of intersection.
Okay, so since y equals negative x, I'm just going to plug that into y for y equals x3 minus 4x. And then have x cubed plus x minus 4x equals 0. X cubed minus 3x equals 0. So now I can take out x, right?
Yeah.
And have x squared minus 3. And then x squared equals 3 and x equals plus minus root 3. That
Say
work?
it again.
So then I can x squared minus 3 equals 0.
Okay.
And then that'd be x squared equals 3.
Mm-hmm.
And then x equals plus or minus root 3.
That's right.
Okay.
Anything else?
Oh, and then could that x also equal 0?
That's right.
That's in front of the, okay.
So we see x cubed, and so when we're solving for x cubed, it's almost like, okay, it's almost like hinting that we can probably have 3 solutions.
I see. Okay. So now we have to plug that y. Okay. So x equals 0 into negative x is y equals 0.
Mm-hmm.
And y equals negative positive root 3. That equals root 3, right? Or negative root 3.
Negative root 3. Right?
And when y equals negative root 3 equals positive root 3.
Right.
So our ordered pair would be 0, 0.
Mm-hmm.
And root 3, negative root 3.
Mm-hmm.
And negative root 3, root 3.
Mm-hmm.
Okay.
So maybe something like this, you have a x cubed graph that kind of has this feel to it, and then you got a line. So it looks like this line is, intersecting at 3 points. Something like that. Or maybe, okay, maybe this is the other direction, probably negative x somewhere. But we get the idea that,
Yes.
with curve, it's possible to have 3 solutions.
Right. Okay.
Okay.
That
Part
wasn't
D.
too bad.
Yeah, not too bad, right? But it's good to get all this factoring practice in.
Yes. Okay. 2D.
Mm-hmm.
Okay.
It's raining pretty hard here. Is it raining hard for you too?
Yes. Very hard.
Yeah. Okay.
So I guess we can do the same thing. Y equals 1 minus x squared. So we can plug that in.
So yeah, set these equal, right?
Oh, right. So x to the 4th minus x squared minus 0 equals 0. And we can take out x squared, right?
Mhm.
That's x squared minus 1 equals 0. So our x is going to equal x equals 0 and x equals plus minus root 1.
Okay. Which reduces to be what?
1.
Mm-hmm.
So we can plug this in, which would be y
Yeah. Does it
equals
matter
1
which one you
minus.
plug into?
No.
No. So we usually just pick what we think is easier.
Yes. So y equals 1 minus 0 equals 1. Y equals 1 minus negative 1, which equals 2. Y equals 1 minus 1, which equals 0. So 0, 1, negative 1, 2.
So here's the thing. With -1, it's actually still going to end up 0. Do you know why?
Oh, because the squared. I forgot about
Yeah.
that.
Yeah, the square is going to take effect before we look at that negative.
Right.
Right. Good.
Okay.
Good. All right. So number 3, I think this will be good to go through all of these. We're going to work with lines a lot in calculus, writing tangent lines. So
Got
I think
it.
it's very, very useful. So number 3, write equations of lines with the following characteristics. I'll review a couple of nice formulas for us to work with here.
Okay.
So passes through. Okay, so a couple of reminders here. There's the slope formula, which is going to come in really, really helpful.
Okay.
There's also points or slope intercept form, which is useful as well.
Mhm.
And there's also point slope form.
Oh, yes.
So when we write an equation of a line, typically we can write it in either form, but we're going to try to stress point slope form because it doesn't look as clean as slope intercept form, but it gets the job done. And a lot of times AP exams will accept this form. So a lot of times we tell students, hey, just even though it looks uglier, it's faster to get to, and there's less room for mistake if you can stop here rather than trying to get all the way over to here. But
Right.
ultimately, they're the same in terms of they produce the same line. Just sometimes one form is easier to get to than the other. Okay. So anytime we want to write an equation of a line, we always stress, okay, find the slope, pick a point, and then you can dump it into the formula. So our first focus is let's try to get the slope between these 2 points.
Got it.
Okay, so how can we find the slope between these 2 points? So we can just choose a point and call it x1, y1.
Okay.
And the second point, we can just call it x2, y2. And then we can do rise over run, changing y over changing x to build the steepness of this line.
I see. Okay. So, oh, so we just, wait. Oh, I see. Yes. Okay. So we just plug it into that.
Yeah, put into the slope
Okay.
formula.
Yeah, I remember doing this. Okay.
Yeah, rise over run.
So 2 minus 4, or we 2 plus 4.
Yeah, that's right. 2 minus -4, which is 2 plus 4.
And then 5 minus 3. So m equals 6 over 3, which is 2.
6 over
Oh, 2.
2, which is
3.
3. Okay. Okay, the slope, we can just set that off to the side. Now, we could do this, but typically we like to just target the slope-intercept form. Sorry, point-slope form.
Yeah, I actually did 5 minus 2 in the denominator instead of 5 minus 3. So that's why I ended
Got
up
it,
with
got it.
6 over 3.
I see. So with point-slope form, we take the slope, insert it for m, and then we can choose either ordered pair to put in. Either one's fine. They may look a little different, but ultimately it's going to come out to be the same equation. So which
Okay.
point do you want to choose? That really doesn't matter.
We could do the 5 and 2.
Okay, so we'll insert, we'll replace the x1, the y1, and the m, and then the y and x will remain as variables.
Okay.
I know this feels incomplete. I mean, we can distribute this through and add to and make it nice and clean, get into slope-intercept form, but this is acceptable.
Okay. So I can just leave it like this? Okay. So this is the answer?
Yeah, that's the equation. Yeah.
Oh.
It doesn't look as pretty as y equals mx plus b, right? If you were to distribute the 3 through, okay, so we could do this. Right, this feels more comfortable, right? It's like, okay, this feels more complete.
Yes, that does.
But, you know, over the course of our year, we're going to try to encourage students to just leave it in this form.
Okay.
Like if they're already going to give you full credit, then why continue messing with something that's already perfectly fine?
Right. Okay.
So another argument is for this is if students spend the time to get it into this form, they're working on something that's already, you know, they could be spending other time doing something else, or if they made a mistake algebraically here, then they will lose points here. And it's like,
I
why lose a point
see.
here when it's already perfectly fine? So,
Okay.
but I know this is kind of a transition period because some students are just wanting to put it in this form, which is fine. You know, you're not going to lose any points if you do it in this form, but it just feels like you're doing additional work where you don't have to.
I see.
Okay, so part B. We want to create a horizontal line with a y-intercept at -4. So sometimes these lines, it's easiest to just graph it and then just convince ourselves what the equation of that line must be.
Okay. So
Horizontal line. Let's just see what that looks like.
okay.
there's my line.
Mm-hmm.
What do you think the equation of that line is?
What do you mean?
So anytime there's a horizontal line,
Mhm.
every point on this graph has a y value of -4.
Oh.
So for horizontal lines, it's always going to be in the form of y equals whatever that number is, whatever that y-intercept is. So this equation is just y equals -4.
Oh, okay.
Because we have infinitely many points that all, imagine lining up all the order pairs that have a y value of -4, and they're all going to form this line.
Okay, that makes sense.
So likewise, see if we can convince ourselves what the vertical line equation will look like. Okay, so vertical line that passes through 7, -8.
Okay. 7, -8. That's going to be x, no. Yes, x equals 7.
X equals 7, right? So if you think about this line here, every point on this line, they all have an x value of 7.
I see. Okay.
So if we string all those infinite many points together, it's going to create that line.
Okay.
Okay, part D.
Okay. Has an x-intercept at 5, y-intercept at -3. Okay. 3D. Okay, so it has an
Well, we
x-intercept.
graph this. Things help.
Yes.
You see it.
So does that mean one like line is crossing through both those points, or?
That's right. Yeah, one line's crossing through both those points.
See.
So we can
So
basically treat D like how we did A, right?
right.
So what points are we working with?
We're working with 5, 0, and 0, -3.
Okay, find slope.
Okay, so that's going to be, I'm going to do -3 minus 5, no, -3 minus 0.
Change in Y.
Over 0 minus 5.
Mm-hmm.
See? So that's going to equal -3 over -5. So 3 over 5.
Yeah, that's my slope. And now I can choose either point to put into my point slope form.
Okay. That would be, we can make that y minus, I'm going to do y minus 0
Okay.
equals 3/5 x minus 5.
It's good enough.
Yes.
Okay.
E.
Mm-hmm.
So it's parallel to the line. 3x plus 4y equals 7 and passes through the point and is written in point slope form. Okay. What would I do?
So it's going to be similar similar steps. It just feels a little more complicated.
Okay.
We're still going to find slope and order pair and put it into point slope form. We already have a
Okay.
point.
Right.
The only thing that we care about this is we just want to find the slope.
Okay. So
I think the easiest way to find the slope of this line is let's get it into, I think in this case, we are going to try to get it into slope intercept form, because if I get in slope intercept form, I can quickly pull the slope just by looking at what's in front of the x.
Okay.
So that's
So
the
y
only
equals
thing that we care about this equation. We just want to pull the slope, and then we're going to erase everything else about this line and take that information and build our new line.
equals mx plus b.
Mm-hmm.
And so we take the 3x plus 4y equals 7 and put it into that?
That's right, put in this form. So we want to solve for y so we can figure out what the slope of this line is.
So could we make it 4y equals 7 minus 3x?
Mm-hmm. I'm going to put negative 3x plus 7.
Okay.
Just so I can get it to begin to look more like that. Okay, next.
And then y equals negative 3x minus 7 over 4.
I'm going to divide everything by 4 here. All right, what do you notice?
Oh, it's in the form.
It's in the form. What's my slope?
See. Slope is negative 3 over 4.
Yeah, so now this is what I want. Now I have everything that I need. Now I'm going to put into my point slope form for my line.
Oh, so now that's just y minus, what was the y value? 4 equals negative 3/4 x plus 6.
Yeah.
Okay.
Good. All right, F.
F.
Similar, but okay. Let's just see how far you can get.
Okay. Okay. Perpendicular. That's the, okay. So
you're going to do the same thing initially.
right. There's going to be 5x equals 3y.
Mm-hmm.
And then y equals, oh goodness. Sorry. Y equals 5x over 3.
Which I'm going to rewrite as y equals 5/3 x.
Okay.
Same thing, just feels like it's matching a little better.
Right. And then okay, so that'll be y minus 7 over 8 equals 5/3.
So what's the slope of this line? It's
5
5/3,
over,
right?
right.
But if we just pull the same slope, then we're creating a line that's parallel to it.
Oh, right.
We want something that's perpendicular. So do you remember what we do with the slope to make something perpendicular?
No.
Okay. We have to do something to it. It's the opposite reciprocal.
Flip it.
And something else.
Negative.
Yeah.
So negative
So
3
reciprocal
over 5.
means we flip the numerator and denominator. The opposite means we change the sign.
I see. So negative 3 over 5.
Yeah. Now we have everything we need.
Okay. So y minus 7 over 8 equals negative 3 over 5, x minus 3 over 4.
Also, another nice thing about point slope form is it's quick to get into the equation, and we don't have to mess around with, okay, combining like terms, common denominator, all that work just to get into point slope form. I mean, to get into slope intercept form, you know, if they will accept in this form, then we just have to stop here.
Less work.
Yeah, for sure.
Okay.
Let's do a little bit from, let me see, 4 is 4 is 4. Yeah, let's just do a little bit of 4.
Okay.
Okay, for the function x squared minus 4x, find each of the following. So we're just inserting these arguments in for x.
I see. So 4 squared minus 4 times 4. So 16 minus 16 equals 0.
That's it.
Okay. Next one is 3 over 2 squared minus 4, 3 over 2. So 9 over 4 minus, could I do where I like cancel out to be like 4, 2, and so then it would be minus 6? Could I leave it like that?
Yeah, that's
Or
fine.
should I?
But if we wanted to find common denominators.
So 9 minus 24. So negative 15 over 4. Okay.
Okay, same process. Just feels a little bit strange with the variable, but.
Okay, cute. So q squared minus 4q.
Yeah.
Okay. And okay, so t minus 4 squared minus 4t minus 4.
T plus 4, right?
Oh, did I say minus? Oh yes, t plus, sorry. Okay.
Okay, let's clean this up.
Yes. So could I do t plus 4 times t plus 4 minus 4t minus 16, and then that'd be t squared plus 8t plus 16 minus 4t minus 16. And then t squared plus 4t. Yeah, minus 0. So, right, or
What did you have here?
I did minus 4t minus 16.
Okay.
Oh, our 16s can cancel. Oh, yeah, because they go to 0. Okay. So then that'd be just be t squared plus 4t.
Yeah.
Okay.
All right, let's do a little bit of, yeah, we can get through all 5. Let's try 5.
Okay. 5. So, same thing?
Similar. We're going to have to make a substitution for f of x and f of 3. And then we can insert into this expression and clean this expression up. So what if f of x was 3x plus 7?
I see.
So 3x plus 7 is going to be a perfect substitution for f of x. We already know that's going to happen.
Mm-hmm.
But I also need a substitution for f of 3. How can I find f of 3?
Can we plug a 3 in for the x?
Mm-hmm.
Okay. So that's going to be so 3x plus 7 minus 9 plus 7.
Well, let's find this value first, and then we can insert it. That way, I feel like this negative is going to mess us up if we. So what's f of 3?
Minus 16.
Yeah, minus 16.
So that'd be 3x minus 9 over x minus 3.
Okay. You said 3x minus 9.
Mm-hmm.
Good. All right. Anything else we can do to get this even further cleaned up?
Not that I know.
Look at the numerator here. What can I do?
Oh, you can do 3x minus 3.
Yeah, I could factor.
Oh, and then we can cancel out the x minus 3's, right?
Mm-hmm.
So then we'd be left with 3.
3.
Okay.
So this has a special meaning when we get into calculus, but we don't know what this really means yet. But really, all this is just kind of getting that practice in terms of, oh, once we understand the concept, are we good with the algebra to get it, to the point that we need to get to? So right now we're just kind of getting the algebra comfortable with it, so that when we get to the calculus and we want to finish up the problem, we can do it without struggling.
I see. Okay.
So let's do part B. Same process. We're still doing f of x minus f of 3. Now we just have a different function and a different value.
I see. So 3x squared minus 2x plus 1 minus. Okay, so 3 times 3 squared is 3 times, so 27 minus 6 plus 1. So that's minus 22. So 3x squared minus 2x minus 71 over x minus 3.
Yeah, let me see here. F of x gets replaced with 3x squared minus 2x plus 1. minus f of 3, which in this case is 22, all over. Is that what you got?
Yes.
Okay, let's clean this up, see if there's anything that we can do to get the numerator and denominator to maybe match, but we'll see.
So 3x squared minus 2x minus 21 over x minus 3. And then, let's see. Can I take out? No, I can't take out this.
Star method here.
What? Oh.
So we got to figure out what multiplies to be a times c, what multiplies to be negative 63, and adds up to be negative 2. So what are factors of 63?
Oh yeah, 3, 1, 30, 63, 3, 9 and 7.
Okay, let's try that.
Oh, and that could work for negative 2.
So what are the signs going to be?
Negative 9 and positive 7.
Okay, so I have to worry about my leading coefficients. So I'm going to have to divide if possible. So negative 9 and 3 reduced to be negative 3. The 7/3 does not reduce, but I can pull this 3 out in front.
Right. And then our x minus 2's can cancel, and 3x plus 7.
Yeah. Okay, let's do 5C, last one here.
Okay. 6 over x minus, so 6 over x minus 2, which is over x minus 3.
All right, so f of 3 is 6 over 3, which is 2. Make our substitutions. So this is a complex fraction. What we're going to do is we're going to try to find a common denominator within this. Then we can find a way to merge this x minus 3 with the result of this cleaned up fraction.
Okay.
So it's a common denominator.
Common, I guess 1.
We want something that both x and 1 can go into.
Oh, this x and 1.
Just x, yeah.
Okay. Oh, okay.
Okay, so now we got to balance the fraction. Here, there's no difference, so there's no balancing needed. We can just pull the 6 down. Here, there's a difference.
Instead of a 1, there's an x.
Yeah, so I need to multiply 1 with x to get to x. So that's why I need to also do the same thing with the numerator. That 2 times x gives me 2x.
Okay. And then all that over x minus 3?
That's right. So now this can become 6 minus 2x over x all over x minus 3.
Minus 3. I see.
Still a complex fraction,
then...
but you know, we have gotten this a little bit cleaned up. So what we can also do now is we're going to try to merge this together. This so dividing by a fraction is same thing as multiplying by the what?
The reciprocal.
Reciprocal. So we're going to push this up as a 1 over x minus 3. So let's see what this looks like.
Okay.
So
can you merge those?
Of trying to get things to cancel out and reduce. Any
Can
ideas?
we merge those two?
Yeah, we can. Let's do that.
So 6 minus 2x over x minus 3. You could take out, for the top, can you take out a 2?
Mm-hmm.
Then be left with 3 minus x over x with x minus 3. But that wouldn't work because that's totally a negative 3 and a positive 3, right?
Mm-hmm. Okay. Is there anything that we can do to get these two to match?
I don't know.
Is there anything else we can factor out of this?
A negative.
Okay, let's try that. What would this look like if I were to factor a -1 out of?
So that would be -2.
Okay.
And then that would be -3 plus x over x. X minus 3, those can cancel out.
These are the same now, right?
Right. So then that would be -2 over x.
Good. Yeah, we're reviewing a lot of nice, important skills that we're going to need in calculus. A lot of students feel that calculus is not hard. It's just all the algebra that comes after it that we just haven't seen in a while and we haven't practiced it. And so a lot of students would make a mistake with the calculus side of things and not so much with the algebra side of things and not so much the calculus. So it's good to get all this algebra practice in what we can. So
yes.
Hey, hold on a second. Let me stop the recording here.
Oh yes.